Thank you for visiting my channel. I am the Actuarial Guy. Please subscribe to receive the latest videos from my channel. We'll now look at the third part of Unit 3, which deals with interest rates. Effective interest, as we have already seen, is considered to be the interest paid at the end of the unit period. For example, an investor lending an amount 1 at time 0 receives 1 plus I at time 1, where I is the effective interest. The nominal interest convertible pithly is the total interest per unit time paid on a loan of amount 1 at time 0, where interest is paid in P equal installments at the end of each pth subinterval. Now the nominal interest convertible pithly is denoted by this, and it is basically the total interest paid throughout the unit period, in our case from time 0 to time 1. But the important feature here is that this interest is paid after each pth subinterval, such that the first payment is made at time 1 over p, the second one at time 2 over p, third one at time 3 over p, and the last one will be made at time 1. Now the amount of interest paid at each of these times is simply given by the nominal interest, convertible pithly, divided by P, where P is the number of times the interest is paid per unit period. For example, if we had a nominal interest convertible monthly, and in which case our unit time would be 1 year, it would simply be I, the nominal interest rate, divided by 12, and the payments would be after the first month, after the second month, after the third month, all the way to the end of the 12th month. Now if you add the interest received in each and every one of these periods, you will simply end up with IP. It's simply the total interest paid. Now when dealing with compound interest, interest itself earns further interest. Now if we take an example where the interest received here earns further interest such that it is compounded for the remaining period up to time 1, and the interest received here is compounded for the remaining period up to time 1, and the same applying for the other interest payments throughout the period, we will end up with the effective interest when all the interest earned and the further interest earned on the interest is added up throughout the whole year. So in our example, when we add up the interest, we simply have IP over P. That's the interest earned in the first pth period, when it's compounded for the remaining period, and then added to the interest received in the next pth period, and that is compounded to the end of the time unit, and we keep on adding them such that we add all the interest received throughout the time period, as well as the interest received here, which is just going to be IP, and no need to compound that because it is received at time 1. So if we add all those, we end up with I, which in other words we simply mean that this is equivalent to our effective interest here. Now this can be rearranged to end up with this formula here, and this formula can be used to work out the nominal rate of interest in cases where you have been given the effective interest or vice versa. Now, the effective discount paid at the start of the period is denoted by D. An example is where an investor lends an amount 1 at time 0 and receives a repayment of an amount 1 at time 1. But then the investor receives an interest of amount D at the beginning of the investment period. In effect, we have the investor receiving D here, so this investment is actually equivalent to the investor investing 1 minus D and receiving 1 at the end of the period. It is 1 minus D here because the investor receives D at the beginning of that investment and receives 1 at the end of the investment period. That is effective discount. In the case of nominal rate of discount per unit time, convertible pithly, we have the nominal rate of discount per unit time convertible pithly as the total amount of interest per unit time payable in equal installments at the start of each pith subinterval. So in other words, the total interest is that, but it's paid in P equal installments such that each installment is dP divided by P, such that and the installments are made at the beginning of each pith subinterval, such that in a time period of 1 as a unit time, the first installment would be made at time 0, the next one at time 1 over P, at 2 over P, at 3 over P, and the last one would be made at time 1 minus 1 over P. Now, if you add up these interest payments, you would end up with that, the nominal rate. And if you discount these payments to the beginning of the period by applying the compound discount model, such that our discounting factor is 1 minus D raised to the power n. This is a situation where we are considering n units of time. So we use the discounting factor 1 minus D. So we discount the first payment by 1 minus D raised to the power 0, which is in effect 1, because it's received at time 0. We do not really need to discount it from any further. This payment, the next payment of received here, is discounted by a time 1 minus P back to time 0. This one is discounted by time 2 over P back to time 0. So in effect, if you add those payments together, you end up with D, which is your effective discount. So D is actually the present value at time 0 of the interest payments. Now, if you can remember, we defined delta to be the nominal rate of interest per unit time convertible continuously. Now, in a case where delta is constant and defining a period dt as a really small period of time, if we multiply delta by dt, it is simply the amount of interest paid over a really small period of time dt, and this interest is paid at time t. So if you take this interest, delta times dt, which is paid at time t, and you accumulate it to the end of the period, time 1, such that you multiply it by 1 plus I raised to 1 minus t, that accumulating it to time 1, and then you take into account all the time periods between 0 to 1, in effect integrating this over 0 to 1 with respect to dt, you are simply working out the effective rate of interest. This gives you the total amount of interest earned over the whole period, unit period, plus the interest earned on interest, such that if you add everything, you end up with the effective interest. Now, I need you to convince yourself that this integral here is equal to this. All I've done here is substitute t for 1 minus t. And as we said earlier, it is equal to I. Now let us work out this integral. We can bring delta to the outside and worry about the rest of the integral here. Now we're going to use this theorem here to simplify this integral. In doing that, we have that the integral of b raised to the power x dx is equal to b raised to the power x ln b plus a certain constant. In our case here, we're going to assume that our b raised to the power x is given by 1 plus I raised to the power t. So, by applying this theorem, our integral here is going to be reduced to this. And popping in the limits, you end up with delta is equal to ln 1 plus I. Now this result is the same result we got in the second part of this unit, the video preceding this one. And if we introduce the exponential, we simply have exponential of delta is equal to 1 plus I. Now with that, we are done with the third part of Unit 3. The final part of Unit 3 will concentrate on force of interest as a function of time. Thank you very much for visiting my channel. Once again, don't forget to subscribe to receive the latest videos from my channel.